Bonjour. Welcome to Wahsa Distance Education Center's radio Zoom classes. This is MBF3C, grade 11 college math, and I am Bronwyn Slate. If you'd like to participate live today, you can call the Wahsa studio at 1-800-465-7144 or 737-4017. You can listen on the radio at 91.9 FM or on the television at Bell Express View channel 972. You are always welcome to join me live through the Zoom link, which is available from me, your teacher, and also your DEC. Our classes are scheduled Monday through Thursday from 11 to 12 in the morning, and we are now in week 9 of our 9-week course. So this is our last week. At this point, you should definitely be submitting work for marking. So a reminder that the support questions, the ones marked with the pencil icon, are not for marking, they're practice questions. So you decide which ones and how many to do. And if you're understanding a concept, feel free to skip questions. But also if you need more practice, let me know and I can send you more practice. The answers are in the back of the booklet, so check your work. However, mistakes have been found. So if something isn't lining up, let me know and we can figure out if that's an error. Key questions, the ones marked with a key icon, are the ones to submit for marking. So please do all of those questions, showing all of your work, your steps and your thinking. This way I can give you credit for all of your understanding and also so that I can understand where you might be going wrong and why. That just gives me a lot more information opposed to just the answer. There are 3 methods for submitting your work for marking. The first is to scan and send your work in electronically. So you can scan in your completed work. If you have a smartphone, you can use an iPhone Notes app or the Android Google Drive app. Both have scan functions. If you're not sure how to do that and need some help, let me know. Or if you just would like to take a picture, if that would be more straightforward, you can do that as well. Then you can either email it to me first to studentwork@nnec.on.ca and CC it to bronwyn.slate@nnec.on.ca. Or you can also send it to me through Facebook Messenger at bslatewahsa. The second method is to drop it off in Sioux Lookout. We have an outdoor mailbox at our address 74 Front Street. We're the big red building next to the post office, and we have a small white mailbox next to our entrance. So you can just put it there. Or the third method is to hand it into your DEC, and then your DEC can either send your work through the Express or fax it to 807-737-1732 or toll-free fax to 1-800-463-7852. If you have any questions or concerns, please contact me. This is why I'm here. So my email address is bronwyn.slate, which is spelled BRONWYN.SLATE@nnec.on.ca. You can connect with me through Facebook at bslatewahsa. You can call the main office and leave a message for me, and then I can call you back. The number is 807-737-1488 or toll free 1-800-667-3703. This week, my office hours are Monday through Friday, 8 a.m. to 2 p.m. But starting next week with the new term, my hours will be 9 to 4. If you'd like to connect with me through social media, both my Facebook and YouTube channel are under the name bslatewahsa, and all of our lessons are uploaded to YouTube in the afternoon after airing, and then I share them on Facebook. So that's a great way to access the replays if you'd like. Also, there are short videos on my YouTube channel that explain common errors or confusing concepts in our course and then lead up to our course. So that can be a great place to go if you're struggling with something to see if there is something that might help you out. Also, I can add more videos. If I notice a common error is happening, I will do a small explanation and put up new videos there frequently. So that's a good place to come revisit if you need to. Math is an incredibly visual subject. So connecting to the videos, either through the live Zoom link or through the replays on YouTube, is really going to set you up for the most success. If you don't have reliable internet and you would like to access the videos, let me know. Then I can send you a USB key or something with all of the recorded videos on them. And so then you can still access those resources. Right, we're on day 33 of our course, and we are doing our Unit 2 review today. But first, let's activate your brain with some mental math. I don't like the policy behind Mad Minutes. They just create a lot of anxiety and stress in students. And so instead of just drilling and killing with math facts, we work on developing strategies that help us become more comfortable with numbers and to find friendly numbers so that we can do arithmetic either by hand or mentally, but using skills and tools that we have. So today's question is 826 take away 437. And this, we're going to use a strategy of place value and negative numbers. This is one of the ones that is a little bit mind-boggling, and it is kind of tricky, but it is the way that people subtract a lot of the time. A lot of people just put the smaller number underneath the bigger number and then just always subtract the smaller number from the bigger number. And so we do something similar, but we use negatives because that's actually what's going on, which means that our amounts become accurate. So anyway, let's dive in and see. So we have 826 take away 437. And so we're going to break it up in place value. So we're going to do 800 take away 400. And we're going to do 20 take away 30. And we're going to do 6 take away 7. Well, 800 take away 400 is 400. 20 take away 30. Well, if I have $20 and I spend it, that means I'm going to be in the whole 10, right? I'm going to have negative 10. And if I have 6 take away 7, the same idea. If I have $6 and I spend $7, that means I'm owing $1 more still. So I'm at -1. So then what we do is we say, okay, 400, we still have a positive value. Take away 10, take away 1. So 400 take away 10 is going to be 390. And then 390 take away 1, because we haven't done that yet, is going to be 389. And so that's what our answer is. 826 take away 437 is equal to 389. And so this way that people often stack and subtract, but the difference is that we are including that this is negative, that we still need to take that amount away from our positive value, opposed to the answer being 411, it's 389, because we still have to actually take away that 10 and 1 amount. This one is definitely a little bit mind-boggling. If it works for you, great, it's another tool. If it doesn't and just confuse you, don't worry about it. Use the tools that work best for you. That's the whole point of all of these, is that we're giving you various tools that might work better for you, not to cause you pain, but to give you different tools that might work for you. So use the ones that work best for you. All right, so again, a reminder of what the final assessment is going to look like now that we're wrapping up our course. I did talk about this yesterday in our previous lesson, but I'm going to talk about it every day this week, just so that you really know, and in case people don't watch every single video. So our final assessment is not going to be an exam. I know that throughout the course I have mentioned an exam, but with COVID-19 and our inability to have folks gathering in places and being supervised for an exam, that isn't going to happen. So it's going to be a culminating assignment. So this is going to cover all of the 20 lessons. So it is still going to cover all of the course material. And it's going to be open book. So you're going to have access to your assignments, to the YouTube videos that I've posted, as well as the other ones that you find, to your IL booklet with the instructions in your IL booklet, to the online tools that we've used in terms of Desmos for graphing or using a scientific calculator, and the virtual manipulatives at Mathagon or other ones that might be useful for you. So you can use all of those tools and any other tools that you might want to complete your culminating assignment. For an exam, you wouldn't have access to all of those things, but a culminating assignment is more of a project. And so you can have access to all of your previous work and resources. It will not be timed, but it will have a deadline. So it's not something that I will send out to you and you will have 2 hours to do like an exam, but instead I will give it to you and you will have 2 weeks or so, depending on the general timeline, to work on it and get it back to me. The structure will likely be slightly unfamiliar. It's going to be different than all of our IELTS booklet questions and the questions that we've done in our YouTube. You're still going to be able to do them, but it's just that instead of me giving you a question that says factor this and then you factor it, it's going to be something that you're going to have to apply your knowledge in a slightly different way. Because it's a culminating assignment and a project instead of a test or an exam, this is why it's going to be slightly different, because just in terms of getting an authentic understanding of what you understand, I need to evaluate you in a slightly different way opposed to just doing computational questions. So don't stress about it, but just be prepared that it will be slightly different than what you are used to. All right, so let's dive into Unit 2 and remember what Unit 2 was about, and then do some practice to review. So Lesson 6 is simple interest and linear growth. So simple interest and linear growth is that simple interest is one representation of linear growth. So it's an arithmetic sequence. And what this means is that the pattern increases or could decrease at a constant rate. So it is changing at the same amount each time. You're either adding or subtracting the same amount each time as time goes on. So our formula for simple interest is I equals PRT, where I is the interest earned in money, P is the principal amount in money, R is your interest rate, is a percent as a decimal, and T is your time in years. So it's important to remember that T, because it's represented in years, sometimes you need to convert. So if your question or your situation is talking about months, well, there's 12 months in a year. So for example, if it was 9 months, then you would do 9 divided by 12 to equal 0.75. That's how many, so 0.75 years is how many 9 months is. Same with weeks, there's 52 weeks in a year. Days, there's 365 days in a year. So the same way that we would convert, you would need to divide by those values. So 60 weeks is 60 divided by 52, which is equal to, and that's an error, I forgot to write the 1. So 60 is greater than 52, so it's going to be 1.15. And 700 days is 700 divided by 365, which would be 1.9. So it's really important to remember that for simple interest, you need to convert your time into years if your question isn't already years. And then if you want to figure out the final amount, you need to add your original principal amount plus your interest amount that you calculated to figure out how much you have in total. All right, so let's do some practice questions. So 1, determine the interest earned on a principal of 800 at 4% for 3 years. So because it doesn't say simple interest, but it doesn't say compound interest, then we know that we're talking about interest. In order for it to be compound interest, which we're going to get to later today, it has to say that it's compounding. So if it doesn't say that, then we know that we're talking about simple interest. So we know that simple interest is I equals PRT. So I like to organize my variables so that I know what I'm talking about. So P is 800. R is 4%, which is equal to 0.04. And time T is equal to 3 years. That's already in years, so I'm good to go. So to put that into my calculation, I have I equals PRT. So that's 800 times 0.04 times 3. And we're going to get our Desmos calculator, or you can use your own calculator. So 800 times 0.04 times 3 equals 96. So my interest earned is $96. All right, number 2, determine the principal if the interest earned was $15.31 at 5.25% for 7 months. And we know we're doing simple interest, so I equals PRT. And here, really, I should have first done, I'm looking to see I, P, R, and T, because I don't necessarily know. In this first one, I was looking for I. So it's good to list all of your variables so you can figure out what it is you're actually looking for, because you're not always looking for interest. So here it says determine the principal. So this time we are looking for P. If the interest earned was 15.31, so my I is 15.31, my R is 5.25%. So that is 0.0525. And my time is 7 months. So to convert that to years, I'm going to do 7/12. I could use this as, I could convert this into a decimal, but I'm just going to put it in as a fraction because it's going to be more exact than if I do 7 divided by 12. It's just not going to be as nice of a number. So it's better to leave it in as a fraction. So then I put my information into my formula. So I is $15.31. P is what we're looking for, so we leave it as P. R is 0.0525, and T is 7/12. So in order to figure out P, I'm going to have to divide both my sides by these amounts. You could do it two ways. You could calculate this first and then do the division. I'm just going to write it all out because this is how I'd like to put in my calculator, because then I'm going to have more of an exact answer. It's going to be the same thing, but this just gives me more of a precise answer if I rearrange completely and then I do the calculation. If you wanted to do 0.0525 times 7 divided by 12 first, it's totally fine. You're just not going to get as exact of a number, which for our purposes probably is fine. So I'm going to do 15.31 divided by 0.0525 times, I'll put this in brackets, 7 divided by 12. It is a little bit messy. So I could understand why you might want to do your division first, just because otherwise it could be a little bit awkward if you're on your calculator, depending, your calculator could screw up, but you do you, whatever works best. So our principal needs to be $499.92. And that's how we would figure out the principal, to that how much we would earn. All right, number 3. $23 of interest is earned on a principal of $1,500 for 30 weeks. Determine the interest rate as a percent to 1 decimal. So again, I continue to like to put down my variables so that I know what I'm looking for and what I'm not looking for. So I is 23, principal is 1,500, rate is what we're looking for, and time is 30 weeks. So that's 30 divided by 52. Again, I'm going to leave it as a fraction. So then I put my numbers in. So I have 23 equals 1,500 times R times 30 divided by 52. So then again, we're looking for R. So this time, why don't I do I'll do this side first. So if I have 1,500 times 30 divided by 52. And so that equals 865.38. So you can see I have to round, and if I'm going to do it this way, which is why I didn't do it in the last example, again, it'll be something pretty close, but just doing it all together means you don't have to round into the end, which is ideal. But $865.38. So then in order to isolate for R, I'm going to do 23. Sorry, I don't want to write it like that. I'm going to do 23 divided by 865.38 equals R. So then I go back to my Desmos and I'm going to do 23 divided by 865.38, which gets me 0.0265, so 0.027. So here I've run out of space, but I can just draw an arrow. R equals 0.027. And then it told me to put it as a percent. So I'm going to multiply this by 100 in order to get 2.7% to one decimal place. There we go. Okay, number 4. How long was a principal of 1,350 invested at 8% if the interest earned was 540? So continue. You can see for all of your simple interests, it is basically the same routine. So I earned an interest of 540. My principal was 1,350. My interest rate was 8%. So that's 0.08. And my time is what I'm looking for. So I equals PRT. I is 540. P is 1,350. R is 0.08. And we're looking for T. So again, just so I don't have to go back and forth to my screen, I'm going to do it all in one go. I'm going to say 540 divided by 1,350 times 0.08 equals T. So back into my Desmos, my calculator, 540 divided by 1,350 times 0.08, which is equal to 5. So my T is equal to 5. And because we know that time has to be in years, so that's 5 years. There we go. Okay, so that was lesson 6. Let's move on to lesson 7. So lesson 7 was compound interest and exponential growth. So compound interest is when we are growing exponentially. So our pattern is increasing or decreasing at a constant ratio. So we're being multiplied by the same amount each time, either a whole number, which means that it's increasing. So it's greater than 1, we're increasing, or at a fraction or a decimal. So a number between 0 and 1, which means that we are decreasing, we're decaying, we're getting smaller. So our formula is A equals P times 1 plus R over N, all to the exponent NT. Remember, my formula that I use is slightly different than the one that's in your IL booklet. We went through this in our lesson, but this is just breaks down all the bits instead of having to remember to do things. We just have to find all of our variables. So A is our final amount, P is our principal, R is our interest rate, of course, is a decimal, and T is our time in years, and N is the number of compounding periods. Or just the amount of interest earned. Then we have to do interest is equal to A, our amount that we calculated, take away our principal, and that finds what our interest is. All right, so let's do some of these questions. So for number 5, part A, determine the amount on a principal of 1,200 at 3% compounded quarterly for 6 years. So because it says compounded here, compounded quarterly, we know that we're going to be doing our compounding questions. So A equals P times 1 plus R over N over NT. And remember, you now know for certain that you're going to have access to all of your notes. So you don't have to memorize these formulas. You need to be able to interpret them and use them properly, but you don't have to have them memorized. So I've listed my variables and I'm going to figure out what it is that I'm finding and what it is that I know. So we're determining the amount. That's how much we have in total. And the principal is 1,200. Our rate is 3%. So that's equal to 0.03. We are compounding quarterly. So remember, quarterly is 4 times a year. And we're doing that for 6 years. So T is equal to 6. All right, so now A is equal to P, which is 1,200 times 1 plus our R 0.3 over n, which is 4, all to the exponent 4 times 6. Then we can go through and do these individually and work through them. I'm just going to do them all into a calculator because that is the way that works best for me. But again, you can do it in parts if you want to do the order of operations. If your calculator is not your friend, that is fine. And if Desmos isn't a good access for you. So we have 1200 times 1 plus 0.03 divided by 4, all to the exponent of 4 times 6. Sorry, press the wrong button there. And that gives us a total amount of $1,435.69. So $1,435.70. First part about this is that my brain sometimes just doesn't remember the numbers at all. So 1435.70 is how I need to remember it. Sorry. So that's how much you would have after 6 years. So then the question B says how much interest was earned. So our interest is found by amount to take away principal. So our amount was $1,435.70. And our principal was $1,200. So we subtract that. So that gives us $235.70 is what our interest earned. All right, and that is really all that we did in lesson 7, because lesson 8, we go into more detail. So lesson 8 was compounding interest formula. So looking at the formula a little bit more detail. So again, for any of our word problems, we need to be talking about compounding. That needs to be in the problem in order for us to know that we're using this formula. And it is best to identify the information given and what you're being asked to find, because you're not always being asked to find the amount. And so it's best to list your variables and figure out what you know and what you don't know so that you can figure that out and you put things in the right place. So if you're finding P, the principal, then you just need to rearrange your formula using algebra to isolate for P. But if you're finding the interest rate, R, you need to use the nth root to isolate for R. So you still rearrange and do your algebra properly to isolate for R, but then you're going to need to take your nth root because R is being raised to an exponent, and therefore we had to do the opposite, have to take the nth root to get rid of that exponent. And then for finding the time length T, we have to use a guess and check to force the bases to be the same in order so that the exponents can be set equal in order to isolate for T. So you can't just rearrange to isolate for T because T is in your exponent. And that way you, what makes it a little bit tricky is that you have to use some guess and check. We don't have any other tools other than guess and check. There are actual mathematical tools, but at this stage, guess and check is our friend. If you need more familiarity of what that I'm talking about in terms of the nth root and guess and check, you need to go back to lesson 8 and look at that again. Totally cool to do. Just if that's what you need to do, you know you. All right, practice problems. So number 6, Dave wins $100,000 in the lottery. How much of his lottery winnings should he invest now at 7.2% compounded daily in order to provide $1 million in 40 years? So we know that it says compounded. So that means that we know that we're using our compounding formula. So our compounding formula is A equals P times 1 plus R over N all to the exponent NT. I like to write down the formula first so that I remember all of my variables. So I need to know A, P, R, N, and T. And now I can go back to my question and figure out what it is that I am doing. So I know that Dave wins this $100,000. So that feels like that's the principal that he has now. But we're just going to hold on that for a second. Because the question is, how much of his lottery winnings should he invest now? So does he need to invest the whole $100,000, or can he invest less, or does he need more? So we're going to say our principal is actually what we're trying to find. And then at 7.2%, so our rate is 7.2%. So that's equal to 0.072. Compounded daily, so that means that our N is 365. in order to provide $1 million in 40 years. So the amount that we want is 1 million and our time is 40 years. So sometimes it's not all laid out in the exact order that we write out our variables. So it's good to figure out a system that keeps you so that your information is organized. Okay, so then we're looking for P. So we're going to do 1 million for our A. You have to make sure that you have enough zeros, is equal to P times 1 plus 0.072 divided by 365, all to the exponent 365 times 40. Now, we can, as always, go through and do these calculations individually, but because our numbers are kind of gross numbers, they're big, we're dividing by big numbers, and we're going to have a big exponent. It is probably best to put it all into your calculator in just one go. Oh, but I forgot. Sorry, my bad. I want to isolate for P, so I'm going to divide both sides by this big, ugly mess. So I'm going to do 1 million divided by, and then 1 plus 0.072 divided by 365, all to the exponent 365 times 40. So you can, and that equals P. So you could do any of these parts and then do the division. That's fine. For me, it's easier to just do it all in one go on Desmos, because then I can see it all and I can see if I've made a mistake. But you need to figure out what works best for you. So 1 million divided by 1 plus 0.072, which is divided by 365 to the exponent of 365 times 40. And that equals $56,150.71. 56,150.71. 56,150.71 equals P. So Dave would need to invest $56,150.71 in order to earn $1 million in 40 days. All right, number 7. A principal of $20,000 amounts to $24,400 when compounded annually for 8 years. Determine the annual interest rate as a percent to 1 decimal place. So again, we're compounding. So A equals P times 1 plus R over N, the NT. With time, you get the practice goes over and over again. It helps. So A equals P equals R equals T equals N equals. So our principal is $20,000. Our final amount is $24,400. We're compounding annually, so we're compounding once as our N for 8 years, and we're looking for the rate. So we have 24,400 for our A equals 20,000 for our P, 1 plus R divided by 1, all to the exponent 1 times 8. So we're going to get 24,400 divided by 20,000 is equal to 1 plus R to the exponent 8. Because R is inside of our brackets to the exponent 8, we need to do this division first. So we have 24,400 divided by 20,000 equals 1.22. Equals 1 plus R to the 8th. So we're going to take the 8th root of 1.22 to figure out, to isolate for R, because 8th root cancels off the exponent 8. So this time we have to do some steps in between in order to calculate this. So the eighth root, you have to figure out how it works for your calculator, of 1.22 is 1.025. 1.025 equals 1 plus r. So we're going to subtract 1 from each side to get r. So 0.025 is equal to r. So that means that 2.5% is what our interest rate is. All right, and number 8, how long was the principal of 500 invested at 4% compounded semi-annually if the amount was 746? This is our last one of these kinds. There are lots of different ways that these questions can be situated. So I'm giving you lots of practice, but we got to race through it so that we have enough time to do our last 2 lessons. So A, P, R, N, and T are what we're looking for. So how long was the principal? So we're looking for time. How long? Principal was 500, invested at 4%. R is 4%, which is 0.04. Compounded semi-annually, so N is 2, twice a year, if the total amount was 746. So then we put that in. 746 is equal to 500 times 1 plus 0.04 divided by 2 to the exponent 2t. So again, we do 746 divided by 500. We're trying to isolate for t. So then we have 1, we can do 1 plus 0.04 divided by 2. So 0.04 divided by 2 is going to be 0.02 plus 1 is going to be 1.02 to the exponent 2t. So 746 divided by 500 is equal to 1.492 equals 1.02 to the exponent 2t. Sorry, I don't know why I wrote that wrong. So now we need to do the guess and check so that we can figure out what 1.02 to the exponent what gets us close to 1.492. So I'm going to just start with 1.02 squared because I really have absolutely no idea. So 1.02 squared is 1.0404. 0404. And I want to get 1.492, so I need to increase by a lot. So I'm going to do 1.02 to the exponent 20. So 1.02 to the exponent 20, and that gives me 1.485, 1.486. Which isn't quite right, but it's pretty close. So I'm going to leave it at that, even though we could probably get closer, but just for the sake of time. So that means that we then replace 1.492 with 1.02 exponent 20 is equal to 1.02 to the exponent 2t. So that means that 20 equals 2t. And so that means that 10 equals t. So it would take 10 years approximately for this. Again, you should spend more time and get it more exact, but because we're running out of time, that's all that I'm going to just ballpark it there. Okay, lesson 9 is loans and RRSPs. So loans is when you borrow money and then you have to pay it back in equal payments over a set period of time, including interest. So your payments are calculated according to how much you want to borrow. So that's PV equals R. So or how much you can borrow is calculated based on according to the payments you can afford. I have them backwards in terms of these situations, but the formulas still are both correct. So PV equals R times 1 minus 1 plus I to the exponent negative N all over I, or R equals PV times I over 1 minus 1 plus I to the exponent negative N. So this is used for loans, RSP, annuities, or car payments. So anytime that you are doing a payment, that you're calculating your payment, these are the formulas that you can use. They doesn't matter the situation. If you're trying to calculate about payments, this is what you would use. So PV is the amount that is being invested. It's the amount that it's worth. It's the amount being financed. The A is the amount of the annuity is worth overall. R is your regular payment. Your I is your interest rate expressed as a decimal per compounding period, and N is the number of payments made in total in years. So you have to include your compounding there as well. So RSPs are saving plans for people who earn incomes. You make regular contributions. So if you have a goal amount, how much you want to earn, you want to have after a period of time, that is equal to A equals R times 1 plus I to the exponent N minus 1, all divided by R. Or if you want to figure out, what your payment could be to make a certain amount, that's R equals A times I divided by 1 plus I to the exponent N minus 1. Again, these variables mean the same thing as on the last slide. So then you pay these regular payments once you retire. So then you can have them paid out as a lump sum, or you can set up an annuity what pays you regularly with your remaining amount being also getting interest earned on it. So it can be a little bit complicated. So investing early earns more interest in the long run. So for these ones, it's really important to figure out which formula to use. So if the question includes one total amount invested or borrowed at simple interest, we use I equals PRT. If you have one total amount being invested or borrowed with compound interest, you use A equals P times 1 plus R divided by N, all to the exponent NT. If you have a loan or an RSP with payments, it might say compounded or it might not, and you're looking for the total amount, you know how much your payment is, you do your PV equals R times 1 minus 1 plus I, all to the exponent negative N divided by I. If you have a loan and RSP with payments and you're looking for the payment amount, you do R equals PV times I divided by 1 minus 1 plus I to the exponent negative N. If you're contributing to an RSP and you're looking for the final amount, then you do A equals R times 1 plus I to the exponent N minus 1 divided by I. Or if you are contributing to an RSP and you're looking for the payment amount, then you're doing R equals A times I divided by 1 plus I to the exponent N minus 1. So I put all of this on one slide so that you can screenshot this or print this off so that all of this is combined in one place. So when you're doing your culminating, this is easy to figure out. So I would strongly suggest saving this one slide because it really helps you figure out which formula to use in which situation. All right, so question 9, a monthly payment of $200 is deposited into an RSP for 25 years and is compounded monthly at 7.75% annually. What is the final value of the RSP? So we're looking, so the monthly payment is R, which is 250. We're doing it for the time is 25 years. Our N is compounded monthly, which is 12, and our I is 7.75%, which is 0.075. And we're looking for our final value. So we're looking for our A. So I'm looking up our formulas because I don't have them memorized. So I'm contributing to a RSP. So A equals R times 1 plus I to the exponent N minus 1, all divided by I. I'm not going to have time to calculate this, but we will write it out. So we have 250 times 1 plus, and remember I is 0.075 divided by 12. We need to keep our compounding effects, our T and our I, and it isn't given to us. sorry, your variables in this one are slightly different. So then our time is, our N is 25 times 12, because again, we're compounding. And then all of that divided by 0.075 divided by 12. So that's how you calculate the final amount that you would have. Then we're not going to do part B because we got to figure out part A in order to do it. But then we could recalculate it in terms of how much, using the payment calculator formula to figure out how much payments we can get. All right, sorry that I had to race through that. I just wanted to touch base on lesson 10. These lessons are jam-packed, so it's a lot to fit in 55 minutes. So buying new, used vehicles and vehicle costs. So calculating a monthly payment for new vehicles, the same payment as before. We also figured out how to complete a deal review. When we're buying a used vehicle, we calculated the resale value based on depreciation rates, how much value is lost, which is V equals P times 1 minus R to the exponent N, where V is the resale value, P is the MSRP, sorry, the price basically. R is the annual depreciation rate as a decimal, and N is the age of the car in years. And then we also talked about costs of owning the vehicle, specifically fuel costs, which we figure out by figuring out how much fuel is consumed by doing your total kilometers used times your fuel consumption rate, and then figuring out how much it costs by doing the fuel consumed times the average cost. And then we also figured out how to calculate monthly cost averages, so how much you would spend in general on a vehicle. All right, so question 10. So an SUV has an MSRP of, so a price of 46,783, and it depreciates at a rate of 25% per year. Estimate the resale value after 5 years. So we have our value is equal to our price times 1 minus R to the exponent N. So our value is what we're looking for. Our price is 460,783, and our rate is 25%, so 0.25, and our years, our time is 5. So value equals 46,783 times 1, take away 0.25 to the exponent 5. So doing that on a calculator, we have 46,783 times 1, take away 0.25 to the exponent 5, which is equal to $11,101.83. So 11,101.83. Sorry, I just wrote that badly. Try that again. $11,101.83 is the resale value. For 5 years. Okay, and then one last question. Josie drives about 25,000 kilometers per year, my bad. The fuel consumption rating of her vehicle is 6.2 liters per 100 kilometers. If the average fuel cost is $1.05 per liter, determine her average monthly fuel costs. So first, we need to figure out how much fuel consumed. And that is our kilometers. So 25,000 times 6.2 liters per 100 kilometers. We need both those parts, right, in order to calculate this properly. So 25,000 times 6.2 divided by 100 equals 1,550. So that's how many liters, 1,550 liters is how much she consumed fuel she consumed in that year. So then step 2 are the fuel costs. And then we do our how much fuel we used. So 1,550 times $1.05 per liter to figure out how much it actually costs. Do that on our calculator and we get $1,627.50. $1627.50. And that's how much it's going to cost her per year. But is that what the question asks? So the question says determine her average monthly fuel costs. So then step 3, I almost didn't answer the question. So monthly means this is our yearly. So we do $1,627.50 divided by 12 to figure out our monthly average cost. So it's really important to read your question. So $135.63 is how much money she spent per month on gas, or on fuel. Okay. So that is the time that we have today. Sorry to race through the end. As always, there's just lots to cover. If you have any questions, please reach out and connect with me, and I'm happy to go through things slower with you if need be. Or of course, you can pause the video or go back to previous lessons where there's much more time to go into more detail about all of these topics. So give me a call at the office if that's the best way to communicate, and let me know when is a good time to call you back. We're still working remotely, so you can't actually call me directly. The number is 807-737-1488 or toll free 1-800-667-3703. If you want to email me directly, my email address is bronwyn.slate, which is spelled BRONWYN.SLATE@nnec.on.ca, or you can connect with me directly through Facebook at B-Slate Wahsa. This lesson, as well as all of our previous lessons, are uploaded onto YouTube. There is an MBF3C playlist on my YouTube channel, so that's an easy way to just find all of our lessons that we've done. So all of the 20 lessons, the videos associated with the 20 lessons, as well as the reviews for this week, will all be under that playlist. So that's a really good place to access all of it instead of just trying to figure out if you're missing any of the lessons or anything. Thanks so much for joining me today. Good luck with your review, and miigwech.